Are there some exceptions in the laws of indices? Actually, we have 12 laws of indices. Now, what are indices? This is 10 I have over here. If I want to shorten this number, I'm going to make it to look like 10, and in top, I'll put 3. Now, this here is what we call the base, and what is on top is known as the power, also known as exponent, and also known as indices. The first law of indices say that if I have a base multiplying a base and this has a power m and n, I'm going to call the base 1 because they are the same, and the power I'm going to add it together. But this law has an exception, so that we can call the exception rule number 1b. So that if I have s is multiplying a base and it have a power m, and this is also multiplying a y and it has a base with a power n. Now this is going to be equals to s multiplied by y, s multiplied by y, and then the base, I'm going to call it just a single base multiplied by the what, single what, base, and then the powers are added together. Why? Because I have it to be in multiplication. Example using the first law A. Now if I have 2 is to the power 3 plus, multiplied by 2 is to the power 4, this is going to give me equals, since the base are the same thing, which is a and a, 2 and 2, I'm going to call it one base, which is 2, and the power, which is m, and I have here to be 3, 4, I'm going to what, add it together. Why? Because they are multiplying. So that this is going to be equal to 2 to the power 3 plus 4 is 7. All right, this is our answer, or you can go on the way to simplify, which is 2 times 2 up to what, 7 places. Find the product of 0.00201 and 0.0021. Find the product of this, leaving your answer in standard form. Now, I'm going to convert 0.00201 to standard form, and I also convert 0.0021. Converting this to a standard form, I'm going to have it to be from here, -1, -2, -3. You stop from where the number started, so I'm going to have 2 points here, 0.1 multiplied by 10 to the power -1, -2, -3. From this one, I have -1, -2, -3. I have 2.1 multiplied by 10 to the power -3. Finding the product of this and this. Product means multiplication. So if I should multiply 2.01 multiplied by 10 raised to the power -3, now the product of 2.1 multiplied by 10 raised to the power -3. This is what I have to find the product. Now, if you look at this expression and look at what I say is the part B of the rule number 1, you find out that this s is the same thing with 2.01, and this 10 raised to the power -3 is something with the a raised to the power m, which is the base. Now, this y is something with 2.1, which is the same thing with 10 raised to the power -3 as I have as a raised to the power what, n here. Now, what am I going to do? I'm going to use the s and y, multiply each other, and then the base, which is a, I'll call it single base, and then the power, I'll add it together. At this point in place, I have that my y, my s is 2.01 multiplied by my s, which is 2.1, also multiplied by a single base, which I have is 10, and then the powers, which is -3 and -3, I'm going to add them together. All right. Now, adding 2.01 and 2.1 is going to give us 4.221 multiplied by 10 raised to the power -3 plus -3. Now, it is going to be 10 to the power -3 plus multiplied by -3 is going to give us -3. Now, this is furthermore equals to 4.221 multiplied by 10 to the power -3, -3. When you have a negative number in two places coming together, you add those numbers together, their power, then it will be on a negative sign. So that if I have -3, -3, I'll add them together, have 6. Now, the answer will be in what? Negative. So that -3, -3 is going to give us 6, but because they are negative, I'm going to put it as -6. All right, so this is example on this. Hope you understand that. Now we are going to move over to the second law. Now the second law is saying that if I have A now is to divide A, which is the same base, and if they have power M and N at this juncture, what you're going to do is we are still going to call it one base, just like we call here. But now because they are dividing, the powers are going to be what? Minus each what? Other. All right. For example, if I have 2 to the power 3 divided by what? 2 to the power 4. This means division, all right? This is also going to be equals because they are the same base. I'll call it a single base. Now the power I'm going to what? Subtract each other. So it's going to be equal to 2 to the power 3 minus 4 is going to give us negative 1. Now this is our answer over here, but this answer is not done. So we are going to put it here. This is under a law of indices. Once we reach there, we are going to complete our answer. Hope you understand this. Now the third law, which I'm going to talk about, is going to reflect to what I have over there, so that if I have A to a negative power, let's say it is negative n, this is going to be equals, now A to the power negative n is A, this negative will form 1 over the A, and this power will still be with what? The n, with an absent of the negative, because the negative has formed 1 over A, abi. Now the n will now come closer to what? The A, abi. Now we are going to use this as our example, so that 2 to the power negative 1 is our example. 2 is representing the base, and negative 1 is representing negative n. What am I going to do? Since it is equals to, the negative will form 1 over what the base is, abi, and then the A, which is the base, will still be there. So I'm going to have negative will form 1 over 2, and 2 will be to the power 1. Okay, which 2 to the power 1 is still what? 2. This becomes our answer. Let's look at another example of this. Let's say find the simplify 5 raised to power negative 2. It's still the same thing. I'm going to have this equals to the negative will form 1 over the 5, which is the base, is now going to be the 2 will come closer to 5. I'm going to have this equals to 1 all over 5 raised to power 2 means 5 multiplied by 5, which is going to give us 1 over 25. All right, that is for rule number 3. Now rule number 4 is when we have a negative power, a 0 power. This 0 power is equals to what? 1. Anything raised to power 0 is 1. But can we prove this? Yes. If A to the power 0 could be written as A to the power 3 minus 3. Yes, because 3 minus 3 is what? Is 0. Now notice that before we have 3 minus 3, it might have been A raised to power 3 all over A raised to power 3. This is the same thing with this. Because from the law of division, I'm going to call it what? 1 base, which is what is here, and the power, which is 3, I'm going to subtract this, which also reflect to this. So this is equals to this, also equals to what? This. And this also equals to A multiplied by A multiplied by A all over A multiplied by A multiplied by A. They are the same thing. A raised to power 3 is what is showcasing here. A raised to power 3 is what is showcasing here. Now, we're going to do some work, which is A will now cancel 1, A 1, 1, A cancel A 1, 1, and then A cancel A 1, 1. 1 multiplied by 1 multiplied by 1 is going to give us equals 1. 1 multiplied by 1 multiplied by 1 is going to give us all over 1. 1 over 1 is going to give us 1. So anything raised to power 0 is 1. This is the proof of it. Now, the next one is going to be a law of infraction index. All right.